This is review problem number 3 for assessment number 7. In this problem, they want you to solve the initial value problem. ds over dt, remember ds over dt, this is like the velocity, equals 28t times 7t squared minus 5 to the third. And instead of giving you something with the velocity, they give you something with the distance. They say the distance with distance formula with an input of 1 is 3. And they want you to find the initial value, meaning what's the initial equation? What was the initial distance equation for this problem? So if they want the initial distance equation for this problem, and they give you the velocity essentially, we need to integrate this. So we can say that S is going to equal the integral of ds over dt, right? If I integrate the derivative, right, it cancels itself out, I'm left with the original equation. So integral of ds over dt, which is equal to the integral of 28t 7t squared minus 5 to the third. All right, so I want to integrate this, and now this is an indefinite integral, so I don't have any x values to evaluate this with. So when I do the integral, I'll get some plus c, and that's kind of what we're trying to find, is what was that c value in the original problem. I can see I have two functions being multiplied, and I have function inside of a function. I'm probably going to need to use substitution. I think the smartest thing would be to substitute this inside version because of the third power. And when we substitute that, you can see the derivative of 7t squared would be 14t, and it will cancel this. So we're going to say u equals 7t squared minus 5. du over dt, so the derivative of u, is 14t. Multiply by dt, you get du equals 14t dt. Divide by 14t, you get du over 14t equals dt. Okay, I can now plug this in, and I forgot to write this here. This would be with respect to t here. So now I can plug in dt for dt here. So I get integral 28t, replace this with the u value that I substituted, and then du over 14t goes here. So now when I multiply this in here, I end up with 28t over 14t, right? Because I end up with 28t du over 14t. These two cancel and leave me just with integral 2 u cubed du. I can actually do the integration here, and when I do the integration on this, I'm going to get 2 u to the fourth over 4 plus c. When I do that integration, right? I add 1 to the power, divide by that number, right? And then add in our constant term there. So remember, this is all s equals this, which means that this is equal to, if I divide 2 and 4, I get 2. So I get u to the fourth over 2 plus c. So now I can say that s equals, plug in the u to the fourth, that's 7t squared minus 5. So I say 7t squared minus 5 to the fourth over 2 plus c. Now in the initial value part of this problem, they tell us that if I plug in 1 for t, my s value is 3, so I can find that c value, and that'll give me our original equation, because I have the original equation here, but I don't know that constant term. What was that number there that when I took the derivative of it, I got this, right? It canceled out, but I got this. I want to know that original constant. So let's go ahead and evaluate that. So we're going to say s of 1 equals 3 here, and we're going to plug in 3 for s, so 3 equals, and we'll say 7, 1 squared minus 5 to the 4th over 2 plus c. So you can see we plugged in the 1 and we knew we were going to get a 3 here. So this is 3 equals 1 squared is 1. So we get 7 minus 5, which we know is 2. So this is 2 to the 4th over 2 plus c. 2 to the 4th is 16. Divided by 2, that's 8. So 3 equals 8 plus c. Subtract the 8 over, and we get negative 5 equals c. So our c value is negative 5. That original constant term was negative 5 there. So we can say our original, our initial value, our original distance formula was 7t squared minus 5 to the 4th over 2 minus 5. And that's our solution to this problem.